The first way of finding the moment of inertia of this thick cylinder is the definitional way. I is the integral of r squared dm, where dm is rho, the density, dv, and the density is in this case the volume density, total mass over total volume, which for a cylinder is going to be total mass divided by the total volume, which is the area of the space times the length. The area is pi outer radius squared minus inner radius squared, pi big R squared minus pi little r squared, times the length. Now, if we wanted to put in an integrate, we are going to be integrating r squared dm, r squared rho dv, that's total mass divided by pi outer radius squared minus inner radius squared, L dv. Now we'll need dv for a cylinder. dv for a cylinder is 2 pi rl dr. And there's our integral. Let's see, that pi cancels out, that L cancels out, lots of constants move outside, and we will have a much tidier looking 2m over big R squared minus little r squared, the outer radius minus the inner radius. Well, that's ugly. We will have to do something about that later. Taking the integral of r to the third dr, what are our limits of integration? We are not starting at 0. We are starting in the inner radius and going all the way out to the outer radius. Finish the integral on your own time. Go as far as you can. Press play to check your work or to get unstuck. Ready? What do you have? Did you cancel out your 4 and your 2 and make you a nice 1/2 m? Oh, we want mr squared. We want mr squared. Unfortunately, we are evaluating r to the 4th, outer minus inner. And then we have that pesky denominator we've been schlepping around for so long. So far, so good. See your way to the end? Need a hand up? Factor. Factor that numerator and simplify. When you've got 1/2 mr squared, you know you'll be good. Pause. Press play to check your work. Look. Difference of two squares. Bam. Bam. Final answer? 1/2 m r outer squared plus r inner squared. Now, let's check our work. If the inner radius decreases and decreases and decreases and decreases and is practically 0, so that this cylinder is practically solid, then this is going to become 0, and we're going to get 1/2 mr squared for a thick cylinder. If the inner radius gets larger and approaches the outer radius and the outer radius and the outer radius and the outer radius until they're basically one on top of the other, and we have a perfectly hollow ring, then we have 1/2 m times 2r squared. The 1/2 cancels out the 2, and we have mr squared for a hollow cylinder or a ring. This is the intermediate case between the perfectly even solid cylinder and the ring, which is completely hollow.